Good afternoon, everyone. Today we are going to start a new lecture, or you can say new chapter actually. In this, we are going to discuss about some mechanical properties of solid. In the previous sessions or up to the previous sessions, we have completed gravitation. We have solved some PYQs as well in the previous lecture. So now we are going to start a new chapter, which is mechanical properties of solid. And this is a very small chapter actually. It will hardly take 2 or 3 lectures to complete it. So let's begin. What we are going to study, actually, what is the purpose of this chapter is the purpose is actually uh, what you can say. This chapter deals with the stress, strain, and some modulus of the solids. So why we are discussing these things? Actually, these things are to be used in the construction of in some construction work, like in the making of roads, bridges. These properties are used. So this is a basic phenomena to be studied before you go into your engineering. There it will be a very important concept. So let's start. And actually, if we see the JEE mains point of view, then few questions, at least one question is asked every year. So, and the question is doable, always doable. So we can do the questions from this topic. So let's start. So first thing is, what is elasticity? What is elasticity means? We have studied some rigid bodies actually in the previous classes in the rotational motion or rigid body chapter. That what is a rigid body? Rigid body is something in which the separation between the particles does not change, or you can say separation between any two particles remains constant. That was the rigid body. But actually, the or you can say practically, the bodies are not completely rigid. When we apply some forces, the separation between the molecules changes. And if we remove the force, then the separation may again change, or it can be, it will become either it will remain same as the force deformed it, or it may again regain their actual shape, their actual positions. So it depends on the body. So what is elasticity? Elasticity is what? It is a property of a body or a matter, due to which or by virtue of which a body tries to regain its original shape after removing of the deforming force. For example, you cannot see actually if I apply a force on this pen in opposite directions, then somewhat its length may change. And if I remove this force, then it may regain its shape. So this property of regaining the shape is known as elasticity. I think it is clear. So what is elasticity? That's clear to you. Now I have discussed, or I'm going to discuss, what is the cause of elasticity. What is the cause of elasticity? The main thing is when you look into a solid, there are various molecules from which it is formed, and the forces, there are forces between molecules. For example, this is a solid. If you see, for example, this is a solid. Let's suppose it has various molecules inside it, like this. And you know that there is molecular forces acting between these molecules. there will be a molecular forces. So if you deform a body, then the molecular force will change and it will try to regain their shape. So what is the cause of elasticity is the intermolecular forces. When a solid is formed, all the molecules are interacting with each other with the help of molecular forces. One thing is clear. What is molecular forces? When a solid is formed, there is a molecular force. There is a force acting between different molecules, and this force is known as molecular force. And in equilibrium, the all the molecules are in steady state, or you can say all the molecules are in equilibrium. It is same as a spring block system. You can consider the situation as a spring block system. Like how? Like this way. These dots, the dots you are seeing here, these dots, these represents molecules of solid. And the spring is representing this spring, these springs are representing the molecular force between them. So each molecule, suppose this is a first molecule, is acted upon by different molecular forces of different molecules. So when you replace or when you deform one of the molecule, like if you displace this molecule, when we apply a force, then the shape of the body deformed. Then this deformation, what is the deformation meaning? Meaning of deformation is that the molecule is displaced from its position, like we have stretched it out like this. Then what will these springs do? They will try to bring the molecule back. They will try to bring the molecule back, and this phenomena is known as intermolecular forces or body. If the molecule returns back to its original position, then the body is known to be a elastic body. Body is known to be a elastic body. If it does not return at all, then the body is known to be a plastic body. And if it returns partially, then the body is known to be partially elastic, which is a general case that we have studied during the time of collisions as well. So what happens till now? The thing is, when you apply a force on a body, that force we will call it as deforming force. We will call it as deforming force. It is trying to deform the shape of the body. Now, when we apply a deforming force, the intermolecular separation changes, due to which the body or the molecules try to regain its shape like this spring block system. And in this phenomena, when the molecules are trying to return to its original shape, a force is applied, and that force is known as restoring force. That force is known as restoring force. So what I am saying, that intermolecular forces creates restoring force, creates restoring force. And this restoring force, if I say in equilibrium, this restoring force, this is a main line, is equals to the external force that we have applied. So this is the main thing that I have told you, that in equilibrium, the restoring forces are equals to the external forces. And what is the cause of restoring forces is the intermolecular forces. So one thing is clear, if you deform a body, some intermolecular forces acts, and the forces created by these intermolecular forces is known as restoring force, and in equilibrium these two forces are equal. That's the thing happening. Now we know that what is elasticity, what is the cause of elasticity. Now we are moving further, and without wasting much time, we are going straight to the topic that is to be discussed as a point of view from the point of view of examination. So what is stress? What is stress? For example, you have a body. Don't take a body. Actually, you can just take your finger. You can take your any of your body part like your hand, and if you try to stretch it out, you will feel some force on your body, on your hand, and this force per unit area is known as stress. You will say now that body is stressed. That what is stress meaning? What is the meaning of stress? The restoring force acting per unit area of cross section is called stress. Now, have a look at that. Have a look at that. What if I say that there is a body like this? This is a body, cylindrical body, you can say. This is a body. And what you do, you applied a force F in this direction and a similar force F in this direction. What will happen? What will happen? These two forces will not create any sort of acceleration in the body. What they create, they will create a stress in the body. One force is acting towards right, other is acting towards left, and these two forces creating a stress in the body. These two forces are creating a stress in the body. So this stress, how do we calculate this stress? Is so what we can write about stress, according to the definition, stress is what? Restoring force per unit area. What is the meaning of FR? Is the restoring force. And what is this area? Area is the cross section area. This is what stress. Now, what I have told you in the previous slide is in equilibrium. In equilibrium, the restoring force is equals to the applied force or external force. Restoring force is equals to the applied force or external force. So what you can write in equilibrium, stress can also be written as F external divided by cross section area. So this is the basic formula that we are going to use while calculating stress. I think the formula is clear to you. What is stress? Now, after seeing the formula, you can write the unit of the stress. What will be the unit? Unit is force per unit area. Force is what? Newton. Area is what? Meter square. So unit is Newton per meter square. This is the stress. I think clear. Okay. So can anyone write the dimension as well? What will be the dimension of stress? I'm giving you 30 seconds. Just write the dimension of the stress. Do you know about the dimension? The dimensional formula. What is the dimensional formula of force? You will say M L T minus 2 divided by what is the dimensional formula of area is L square. So it will become M L minus 1 T minus 2. This is the dimensional formula of stress. Now, depending on the applied force or uh, the direction or the force, the dimension of force or whatever you say, depending on the force, we can identify the type of stresses. What type of stress is, or you can say, depending on the change in shape of the body, we can identify the stress type. What is the type of stress? For example, stress is basically can be defined as of three types. So what are the types of stress? Three types of stress basically are there: longitudinal, tangential, and volume. I will discuss them one by one: longitudinal, tangential, and volume. Okay. So let's start with the first, longitudinal stress. What is longitudinal stress? What if I say, if the applied force, if the applied force are perpendicular to the surface, listen to me very carefully. If the applied force are perpendicular to the surface, then the stress is known as longitudinal stress. Have a look at that. When the applied force are perpendicular to the cross section area, then the stress is known as longitudinal stress. Again, longitudinal stress is of two types. Can you visualize the situation when the applied force is perpendicular to the cross section area? Yeah, you can definitely realize it by saying, suppose this is a body. This is a body. And the forces are applied like this. These forces are perpendicular to the cross section area. So the stress in this case is known as longitudinal stress. And this longitudinal stress may be of two types. Either these forces are pulling the body, or there may be a situation that these forces are compressing the body. So these forces are again of two types. These stress is again of two types: tensile and compressive. What is tensile stress? If these forces are pulling the body, if these forces are pulling the body, then the stress is known as tensile stress. And which, if these forces are compressing the body, then the stress is known as compressive stress. I think it is clear. Yeah. So what is tensile stress? Have a look at that. This is a rod which is fixed at one end of the wall, and we have applied a force F in this direction. So in this situation, let the area of cross section is A. So the stress produced in this scenario is tensile stress. Is tensile stress. So what you learn from the tensile stress is, when elongation is produced, or I will say, when the force tries to elongate the body. When the force tries to elongate the body, then the stress is known as tensile stress. I think it is clear. Now, again, moving further, what is compressive stress? The opposite of the previous one. If you apply the force in this direction, then this force will try to compress the body, and the stress produced is known as compressive stress. Let the area of cross section is A. So what can you write here? When the force tries compress the body, then the stress is known as compressive stress. But one thing is for sure that both these stresses are longitudinal stress because in both the cases, force is acting perpendicular to the surface. Perpendicular to the surface means this is the cross section area and the force is perpendicular to this area. So this is known as longitudinal stress. The longitudinal stress is of two types, tensile and compressive stress. Moving further. Another stress is tensile tangential stress. It is also known as somewhere shearing stress. This is the another name of the tangential stress. What is it? In the previous slide or in the longitudinal stress, what we have told you that the force is perpendicular to the surface. Now, if the force is parallel to the surface, then the stress is known as tangential stress. Have a look at that. When the force is parallel to the face of the body, have a look at the diagram. Suppose, have a look at this. This is a body, original shape of the body, initial state you can say, and we have applied a force F in this direction and F in this direction on opposite faces. Like this. You have a notebook, you have a book actually, like you can see you have a book. And what if you apply two forces, one in the forward direction, one in the reverse direction, like this? So the shape of the body is changing. You can see it here. This is the original shape of the body. If I turn off the blur like this. Yeah. Can you see the change in the shape of the body? This way. This is the original shape. This is the change in the shape. So one more thing that I need to tell you that tangential stress is just for changing the shape of the body. The volume of the body remains the same while in the case of tangential stress. I think the point is clear. The volume remains same. What changes? Only the shape of the body changes. Only the shape of the body changes. So now, I think it is clear to you tangential stress is what? Again, tangential stress will be force per unit area. Force is what? F. Area is what? A. So what is tangential? Force per unit area. Formula remains the same. No change. Again, moving further. Another case is volumetric stress. This is an important aspect of the phenomena. What is volumetric stress? If I say, let's say there is a body. This is a body and like this. This is a body. And on every part of the body, there is a force acting F. And the main thing is the force is perpendicular to the surface at each point. If you see the force F, this is perpendicular to the surface here. This is perpendicular to the surface here. This force is perpendicular to the surface here. This force is perpendicular. This force is perpendicular to the surface. So what is the volumetric stress? When the force acts on a body normal to the body at every point, then the stress is known as volumetric stress. Clear? What is the difference between longitudinal and volumetric stress? In longitudinal stress, only one dimension of the body is changing. Let me show you. Let me show you. In longitudinal stress, the force is changing only one dimension of the body. That is, in this case, that is the length of the body is changing. While in case of volumetric stress, in case of volumetric stress, the whole shape of the body is changing. whole shape of the body is changing. If you see, if I continue applying this force, then you can see that this portion will get compressed, this portion will get compressed, this portion, all the portion will get compressed, and the body will look like something this way. This will be the new shape of the body, because from all the directions, the body gets compressed. So this is volumetric stress. I think name is clear. All things are clear. What is the difference between all these? First is longitudinal stress. Longitudinal stress, the stress in which forces are perpendicular to the cross section area. These are of two types, tensile and compressive. In tensile, the nature of force is of pull type, and in compressive stress, nature of force is of push type. In one, next is tangential stress, or you can say shearing stress. In this case, the force is parallel to one of the surface, one of the face of the body. In tangential stress, volume of the body remains same, only the shape of the body changes. Next is volumetric stress. In volumetric stress, what happens? The force is again perpendicular, but perpendicular at every point, and all the dimensions of the body changes like this on your screen. So after the normal study, we will go towards a concept test. Let's try to solve this question that is on your screen. I will give you 1 minute of time. Let's try to solve it. I am just giving you 1 minute time. So just try to solve it out. This is a very basic question actually. I'm waiting for 1 minute. Can anyone answer the question? Okay. Let's try to solve it out. What question says? A load of 4 kg is suspended from a ceiling, okay, through a steel wire of radius 2 mm. So now stop it here and try to draw the diagram. What it says, there is a ceiling like this, and a load of 4 kg is suspended from a ceiling through a steel wire. So first of all, make a steel wire. This is a steel wire which has some radius. This is a steel wire. It has some radius 2 mm. Now a block of 4 kg. This is a block of 4 kg is suspended from it. I think it is clear. 4 kg is suspended from it. Find the tensile stress developed in the wire when equilibrium is achieved. What will happen? What if I say, first of all, in equilibrium, the case is of equilibrium, this 4 kg weight, this 4 kg block will exert a force of 4g. 4g, mg kind of feeling, 4g. And this force is felt by this wire, by this steel wire. So F external on this steel wire is 4G. In equilibrium, I have told you that external force is equals to restoring force. So what is stress? Stress is what? Restoring force per unit area. Restoring force per unit area. You will say, sir, restoring force is what? 4G, 4G divided by G is what? Acceleration due to gravity. And area is what? Pi. Area of this cross section area is nothing but pi r square. Now I will place the value 4, and they are saying take G as 3.15. So I will place 3.15 in place of G divided by pi and r square. R is the radius. Radius is what? 2 mm. Radius is what? 2 mm, which is 2 into 10 raised to the power minus 3 meter. I think it is clear. Pi r square, if I square it, it will become 4 into 10 raised to the power minus 6. You can cancel things. Pi will cancel pi, 4 will cancel 4. So what is the stress? 3.1 into 10 raised to the power 6 Newton per meter square. This is your answer. This is a very simple question actually. You can easily solve it. Now, there is another question on your screen. Have a look at that. This is the next question on your screen. This is also a very important question. It will clear a lot of doubts in your mind. Take 1 minute of time in solving the question. Question says that there is a cuboid thing. This side is 5 meter, this is 2 meter, and this height is 1 meter. Cuboid is given, and a force of 100 Newton is applied on the top surface at an angle 30 degree from the horizontal. And the block is fixed with the supports. These are the two supports on which block is fixed. What you need to calculate, find longitudinal and tangential stress on the fixed block on this block. So longitudinal and tangential stress you need to find. The force applied is 100 Newton. Can anyone give me the answer? You can actually solve it very easily. Okay. So moving towards the solution part. Anyone who has solved, answer the longitudinal stress. Okay. So first of all, just recall the definition of longitudinal stress. What is longitudinal stress? When the force is perpendicular to the cross section area, perpendicular to the surface. Can you see that this force is not perpendicular to the surface? This 100 Newton is not perpendicular to the surface. So can we resolve this force in its components? Yes, we can. What will be the two components? You will say the two components will be, this component will be 100 sine 30, and this component will be 100 cos 30. Is it visible? No, I don't think it's very much visible. I will say 100 cos 30. So these will be the two components. Now, for longitudinal stress, what is longitudinal stress? Force per unit area. Force is what we need to consider perpendicular force. We need to consider perpendicular force divided by area. This is the definition of longitudinal stress. So perpendicular force is now what? 100 sine 30. This is F perpendicular. So what will be the value of longitudinal stress will be 100 sine 30 divided by area. So what is the area of this top surface? Area of this top surface is 5 into 2. That is 10. Now, if you solve it, you will get 0, 0 will get cancelled out. Sine 30 is 1 by 2, so it will become 5 Newton per meter square. This is longitudinal stress. I think it is clear. Now, if I say what will be the tangential stress? Tangential stress. What is tangential stress? Just recall. Tangential stress is what? When the force applied parallel to the surface, parallel to the body. So, which of the force is parallel to the body? 100 sine 30, 100 cos 30, or 100? Which of these is parallel to the surface? You will say 100 cos 30 is parallel to the surface. So, I will write as F parallel to the surface divided by area. So, F parallel to the surface is what? 100 cos 30 divided by area is again 10. Area of what? Area of this face at which force is applied. And area of that face is 5 into 2, 10 meter square. Again, 0, 0 will get cancelled out. This is 10. Cos 30 is what? Root 3 by 2. So it is 5 root 3 Newton per meter square. I think it is clear. Both these questions are clear to you. Now we will again move further. Now we will discuss if a stress is developed or if external force is applied on a body, it may deform the body. It may deform the body. And due to this deformation, we are going to calculate strain in the body. So what is strain? Strain is a ratio. Strain is a ratio of what? Change in the shape of the body divided by original shape of the body. Or shape is measured as in the form of dimensions. Either length will change, or you can say volume will change in the volumetric stress, or there is a case of twisting. Like in tangential stress, what changes the body shifts from one side to another. So there will be three kind of strains as well. So what is strain? Change in any dimension to its original dimension. If the length of the body is changing, then how we will decide the strain? The change in length to the original length. This is strain. Nothing special in it. So what is longitudinal stress? Longitudinal strain. Okay. So what is longitudinal strain? Suppose consider this is a rod. Longitudinal strain is produced by longitudinal stress. This is a simple thing that I need not to discuss actually. Longitudinal strain is what consider there is a body, there is a rod which is fixed at one end and one end is open. Now, if I apply some force on this end like this, then the rod will get stressed. Rod will get stressed like this. Again, if I say, suppose the original length of the rod was L, and after applying force, it has increased by a length of delta F. It has increased by a length of delta L. Then this longitudinal strain or any kind of strain is change in dimension to the original dimension. What is the change in dimension? You will say delta L is the change in dimension. So delta L divided by original length L. This is what longitudinal strain. What will be the unit of strain? Unit of strain will be unitless because this is the length, both are the length, so it is unitless. Okay, is it clear to you? Now, another thing is volumetric strain. Another thing is volumetric strain. Are you getting all these things? The phenomena that we have studied, the main thing that you need to remember is longitudinal stress, tangential stress, and the volumetric stress. After that, there will be certain things like strain. Let's start volumetric strain. What is volumetric strain? The strain corresponding to the volumetric stress. Have a look at that. This is a body. This is a body and it is applied by some forces F, like some equal forces F are applied on it, like this. And all these forces are perpendicular to the body at every point, like this. Now, what these forces will do? These forces will shrink the body, and the body will look like that after a certain point of time. So, what I'm saying that there will be a change in volume of the body, and this change in volume of the body divided by the original volume is known as volumetric strain. So, how can we write it at volumetric strain is equals to, let's suppose the volume changed of the body is delta V divided by the original volume that was is V. So volumetric stress is delta V over V. Is it clear? Again, it is a unitless quantity. It is a unitless quantity. Clear? I think it is clear to you. Next is shearing strain. What is shearing strain? The strain corresponding to shearing stress. Have a look at that. You can read it as, have a look at the diagram first. This is the diagram. Have a look at that. The dotted line, this dotted line, let me took a laser pen. These dotted lines are representing the original body. Clear? This is the original body. Have a look at that. And the bottom of the body is kept fixed, like it may be placed on a rough surface so that it's just fixed. And at the topmost surface, a force F is applied towards right. A force F is applied towards right. Due to this force, the shape of the body changes. As the bottom layer or the bottom surface of the body was fixed, only the top layer deforms. Only the top layer deforms. So this deformation is known as shearing strain. How it can be calculated? It can be calculated as like this. It is defined as the angle should be considered in radians, through which a plane surface of a cubical body gets turned, like this. This was the original top surface in the form of dotted lines. It gets deformed by distance x, and the angle rotated by it is theta. Angle rotated by is theta. So how it can be written as, so shearing strain, what we need to do, we need to calculate the angle. So what if I calculate the tan theta? Tan theta is what? Perpendicular, that means x divided by base is what? L. As we all know that in case of solids, this angle will be of very small size. So tan theta can be written as theta, and theta is what? X divided by L. This is what? Shearing strain. This is what? Shearing strain. So shearing strain is what? Tan theta, it can be defined as X by L. What is X? X is the displacement of the top layer, and L is the perpendicular distance between the two layers. Two layers of what? One is fixed layer, another is movable layer. I think it is clear to you. So let's just summarize the things one by one. Let me just not get confused about there are so much definitions in it, so I'm not going forward with a lot of more definitions like Hooke's law, etc. things. I'm just keeping things, ending things here so that you can remember the things. First of all, what we have studied about the elasticity. So what is elasticity? What is the cause of elasticity? Cause of elasticity was intermolecular forces. Intermolecular forces. When the separation of when the body is deformed, then the intermolecular forces tries to bring the body back, bring the shape of the body back. And in equilibrium, what I have told you, these restoring forces are equals to the external forces. That's what we have studied. I think you remember the things like this. So what is the cause of elasticity? Intermolecular forces like this. And we have uh, produced the analogy of spring block system as well. I think it is clear to you. Next, we have studied the stress. What is stress? Stress is of two or three types. Three types. What are the three types? Longitudinal. Second was tangential. Third was volumetric stress. Clear? So not going a lot of we are not going to discuss lot of things here because it will create a mess in your mind actually. So what we are going to do, we are going to end the session here. In the next session, we will discuss some Hooke's law, some bulk modulus, some Young modulus things. And after that, in the next lecture, we will do some PYQs, and the chapter is very small actually, so it will not take a lot of time. So till then, keep studying, and goodbye everyone. I'm ending the session.